Alright class, in this session we are going to start exercise 21.2, which includes area bounded by two curves, right? As an example, I have pasted a picture here. You can see that there are two curves and we need to find out the area of the shaded portion. That is meant by area bounded by two curves, right? And how we are going to do that, I have taken example number 9 from your book. So firstly I will explain the example and then I will ask you to attempt the questions by yourself. So first read it out. Diagram shows part of the curve y equals to x square minus 3x plus 6, that is your curve, and the line y equals to x plus 3. Find the coordinates of A and B. Now this part is from the simultaneous equation, right? You have an equation of curve and you have an equation of line. The curve and the line intersects at the point A and B. So y equals to x square minus 3x plus 6, equation of curve, y equals to x plus 4. So first we need to solve them simultaneously. If I place the value of y, this y here, so it will be x plus 3 equals to x square minus 3x plus 6. Now you need to solve it simultaneously, right? Find out the values of x. You will get two values of x, and with those two values you will get two values of y. So first give it a try, and to complete this question you have a time of 3 minutes to find out the coordinates of A and B. So start. Alright, if I arrange the equation first, so it will be x square minus 3x minus x plus 6 minus 3 equals to 0. X square minus 4x plus 3 equals to 0. So middle term is x square minus 3x minus x plus 3. Taking common x minus 3 minus 1, x minus 3. Again taking common x minus 3, x minus 1 equals to 0. And you have got two values of x equals to 3, x equals to 1, right? We have equation y equals to x plus 3. So I will place the value of x here one by one. So when x is 1, add x equals to 1, so y is 1 plus 3, 4. Add x equals to 3, so y is 3 plus 3 is 6. So I got two values. When x is 3, y is 4. When x is 1, y is 6. Alright? When x is 3, y is 6, and when x is 1, y is 4. So from the figure we can identify that this is my point A and this is my point B. Alright, so that is your first part. After that we need to find out the area of the shaded portion. Area. First we are going to find area under the line here, right? The equation of line we have y equals to x plus 3, and you can see that the L and M coordinates will be the x coordinate of A, it's 1, and the x coordinate of B, it's 3. So we have the limits from 1 to 3, right? That is the equation of line. And for equation of curve we have y equals to x square minus 3x plus 6. So firstly you need to find out the area of these two line and curve and then place the value, and for this part you have a time of 3 minutes to find out the integration of these two equations, and then I will tell you the right answer. So start. Alright, so firstly the integral of x plus 3, it's x square upon 2 plus 3. Limits we have, it's from 1 to 3. So upper limit 3 square is 9 upon 2 plus 3 minus lower limit is 1 upon 2 minus 3. Alright, 3 and 3 cancel, so 9 minus 1, 8 upon 2 leads to 4. That is the area under the line. For area under the curve, the integration of x square minus 3x plus 6, it's x cube over 3 minus 3 x square upon 2 plus 6x, and the limits is same, it's from 1 to 3. 3 cube, it's 27 upon 3 leads to 9 minus 3 square, 9 3s are 27 upon 2 plus 6 3s are 18. Alright, that is my upper limit minus lower limit. It's 1 upon 3. I need to write it separately because the space is very limited here. So this one 2 3. So it's 3 cube 27 upon 3. It's 9 minus 27 divided by 2 plus 6 3s are 18. Upper limit minus lower limit. It's 1 upon 3 minus 3 upon 2 plus 6. When I expand the bracket here, so 9 plus 18, it's 27, right? So 27 minus 27 upon 2 minus 1 over 3 plus 3 over 2 minus 6. Alright, so 27 and 6. 27 and 6 can be simplified. So 27 minus 6, it's 21 minus 27 upon 2 minus 1 upon 3 plus 3 divided by 2. Now the equation, we can take LCM here. So LCM will be 6. 21 into 6, 6 1s are 6, 6 2s are 12, minus 2 3s are 6, 27 3s are, let me confirm it, so 27 times 3, it's 81. Alright, 3 2s are 6 2 plus 2 3s are 6 9. So 126 minus 81 minus 2 and plus 9. So it's 52 divided by 6 gives you the value of 8.66. Alright, that is my area of the curve. When you observe area of the line, so the integral of 3, it's 3x, right? So for 3x, if you apply the limits here, so 3 square is 9 upon 2 plus 3 3s are 9 minus lower limit is 1 upon 2 minus 3. So 9 upon 2 minus 1 upon 2, 8 upon 2 leaves 4 plus 9 minus 3, it's 6. So 4 plus 6 is 10. Now if you observe from the figure, you can see that shaded region is area under the line minus area under the curve, right? Shaded area is equals to area under the line minus area under the curve. Area under the line is 10, area under the curve is 8.66. When you subtract, it gives you the value of 1.33. That is the area of the shaded portion. Alright, so that is the example, and this thing we are going to attempt in upcoming questions, that how to find the shaded area between a line and a curve. Alright, I hope this example clears to you. It is from your book example. It is the, it will have the solution in your book. If you want to see the book solution, you can easily access it. Now after that, after this example that is quite lengthy, we are going to start from the book questions. It's exercise 21.2, question number 1. There are 3 parts, A, B and C. We are going to attempt any 2 of them, and you will attempt the third one, right? So the homework part is part B, and we are going to attempt part A and part C here. So let's start from part A. For each of the following, find the x coordinate of the point P. So you need to find out the x coordinate here and calculate the area of the shaded region. So for P, we have two equations, y equals to 2x and y equals to x squared. So what do you need to do? You need to find out the value of P by the concept of simultaneous equation we have done in the previous part. So give it a try first. You have a time of 2 minutes, and then I will explain. So start. Alright. So I can say that x squared equals to 2x because I place this value in this equation, right? If I arrange the equation, so x squared minus 2x equals to 0, x common, so x minus 2 equals to 0. We can say that x equals to 0 and x equals to 2. So the origin point is where x is equals to 0. So for P, the x coordinate is 2 for point P, right? So this value here on the x-axis, it's 2. That is your first part. After that, we need to find out the area of the shaded region, and to find the area of the shaded region, our approach is what? We need to find area under the line and then subtract area under the curve. That is my main equation, right? So you need to find out the area of line separately. For line, area of line, the equation we have, it's y equals to 2x. Integrate the equation, apply the limits from 0 to 2. For area of curve, the equation we have y equals to x square. Integrate the equation, apply the limits. So first find out the value of area of line and area of curve, and then I will tell you the correct answer. And for this part you have a time of 3 minutes. So start. Alright. So y equals to 2x, when you integrate it, it will be 2x square divided by 2. Left over only x square with the limits of 0 to 2. Upper limit is 2 square, 4, lower limit will be 0. So that is your area of line. For area of curve, integration is x cube divided by 3. Limits we have, it's from 0 to 2. Upper limit 2 cube is 8 divided by 3. Alright. So if I place my both values in this equation, so area of shaded is equals to area of line, that is 4. Area of curve, that is 8 divided by 3. LCM 3 4s are 12. 12 minus 8. It leads to 4 divided by 3. That is your first part answer. Alright. I hope that it is clear to you. And for part C, you need to attempt this whole question by yourself, and then I will tell you the way how to attempt it, what are the things we need to find, and this equation, the equation I've made here, you need to make the same exact equation and then try it by yourself. So for this C part completely, you have a time of 4 minutes. Alright, so start. Alright, so I expect that you have tried something, and first let me place the picture here so it won't bother me to scroll up and scroll down again and again. Alright class, so first we need to highlight the point x coordinate of point P, and the equation of line we have, it's y equals to 2x. The equation of curve we have y equals to 8 minus x square. The final, if I place the value of y here, so it's 2x equals to 8 minus x square. Arrange the equation, x square plus 2x minus 8 equals to 0. Now that is a quadratic equation, right? And the factors we have is 4 and 2, so x square plus 4x minus 2x minus 8 equals to 0. Taking common, it's x plus 4 minus 2, x plus 4 equals to 0. Again taking common, so x plus 4 and x minus 2 equals to 0. So the values I'm getting here, x equals to negative 4 and x equals to positive 2. So since we are dealing on the positive side, that means the x coordinate of P, it's 2. Right, so that is the x coordinate and it's 2. Alright. After that we need to write down the equation, the main equation of area of shaded portion is equals to, we need to find out the area under the curve and then subtract area under the line. Alright. First I'm going to start with the curve. So the equation of curve we have, it's y equals to 8 minus x square. If I integrate it, it will be 8x minus x cube divided by 3, and the limits we have is from 0 to 2. So 8 2s are 16 minus 2 cube is 8 divided by 3. Taking LCM, it's 3. 16 3s are 48 minus 8. It leads to 40 divided by 3. That is the area of the curve we have, right? For area of line, the line we have, it's y equals to 2x, right? So if I integrate, that will be 2x square upon 2, left over with x square, and the limits we have from 0 to 2. The upper limit is 2 square is 4. Alright. Now the shaded area we have decided earlier that its area of the curve 40 upon 3 minus area of line, that is 4. If I take LCM here, that will be 3. So 14 minus 3, 4s are 12. So 14 minus 12, it is equals to 30 and 28. So it's 28 divided by 3. Alright, and that is your answer. So you have observed that now we are getting the question in which first we are applying the concept of simultaneous equation to find out the point of intersection, and then the same method that we are going to integrate the equations to find out the area below the shaded below the line or below the curve, right? And once you have the area, then you need to identify from the graph that which area needs to be subtracted from which area. Either it's area of line subtracted from area of curve, or area of curve subtracted from area of line. That things needs to be identified from the figure. Alright, now moving on towards the next question. It's question number 2. The diagram shows a shaded region bounded by the curve y equals to x square and y equals to 8 minus x square and the y-axis. Find the area of the shaded region. Alright, so the working strategy is, let's suppose if I'm going to pick the area of this portion, right? 8 minus x square. Now listen to me very carefully. If I'm going to find the area under the curve y equals to 8 minus x square, so that means this whole area is under the curve 8 minus x square, right? Or secondly, if I find the area of this portion under the curve, the area under the curve will be this one. And if I subtract the two areas, so I will get this one, right? That is my working area of shaded is equals to area of y equals to 8 minus x square minus area of y equals to x square. That is our working to find out the area of the shaded portion. So we are going to start step by step. At first I'm going to pick the equation y equals to 8 minus x square. We need to integrate, substitute the limits here. After that we need to pick y equals to x square, similarly integrate it, applying limits. And then we need to subtract the area of these two. So first you need to give it a try by yourself, and time is 4 minutes, so start. Alright, when you integrate it, it will be 8x minus x cubed divided by 3. The limits we have is from 0 to 2. So it's 8 2s are 16 minus 2 cube is 8 divided by 3. LCM 48 minus 8, it's 40 divided by 3. That is my area of y equals to 8 minus x square. Now for y equals to x square, if I integrate, it will be x cubed divided by 3. Limits we have from 0 to 2. Alright, so upper limit it's 8 divided by 3, and lower limit is 0. Now the area of the shaded is area of y equals to 8 minus x square, it's 40 divided by 3 minus 8 divided by 3. 40 minus 8, it's 32 divided by 3. And this is your final answer. So the working is quite similar as the previous one, that we need to find out the area of the two curves and then we need to subtract it. The thing you need to highlight is which area needs to be subtracted from which area. That is why I have explained the part by using the highlighter in this question. Alright, now moving towards the next question. Alright, so it's question number 3. It says diagram shows part of the curve y equals to 2x squared plus 3 and y equals to 3x squared plus 2 intersecting at 1, 5. So you have this point, right? 1, 5, this one. Find the area of the shaded region. So what we need to do here, there are two ways. At first, if you think that by using the limits of y-axis you can find out the area, so that you are right, you can do that. But to find out the values of y and make the equation in terms of x, it will be a little bit lengthy question, right? So what I am doing here, first I will find the area of y equals to 2x squared plus 3. That means this area I am going to find out, right? y equals to 2x square plus 3, this area from 0 to 1. And if I am going to find the area of y equals to 3x square plus 2, its area under the curve, that means we had find this area as well. So to find out the shaded area, we need to subtract these two areas, right? So the main equation, area of shaded portion equals to area of y equals to 2x square plus 3 minus area of y equals to 3x square plus 2. So first you need to give it a try. First you have a time of 3 minutes and then I will tell you the answer, so start. So if I start from y equals to 2x square plus 3 integrated, so that leads to 2x cube upon 3 plus 3x. Limits we have from 0 to 1. Upper limit it's 2 upon 3 plus 3. After taking LCM it's 2 plus 9 divided by 3 leads to 11 divided by 3. Similarly, for the next equation, y equals to 3x square plus 2 integrated, it will be x cube upon 3, 3 and 3 cancel, plus 2x, and the limits we have it's from 0 to 1. So now it's 1 plus 2 leads to 3. Alright, the area for the shaded portion is, area of shaded is 11 over 3 minus 3. Taking LCM leads to 3. 11 minus 3, 3s are 9, leads to 2 divided by 3. Alright, and that is your final answer. So I hope that all of you are clear in this part, and I mentioned the homework in the beginning of this class that you need to attempt one part of question number 1, and that was one part B. That is your homework. Alright, so see you in next